If you ask most folks if we're alone in the universe, they'd probably say no way. Scientists tend to agree there should be tons of intelligent aliens out there. Some might even be way more advanced than us humans. To describe how sophisticated alien civilizations could be, researchers came up with something called the Kardashev scale. Looking back at human history, it's clear that as intelligent species develop, they use more and more energy. More advanced tech means more power consumption. So how much energy is used can show how advanced a civilization is. Back in 1964, astronomer Nikolai Kardashev split hypothetical alien civilizations into 3 levels based on their energy use. He said a level 1 civilization can harness energy on a planetary scale, level 2 on a stellar scale, and level 3 on a galactic scale. Later, astrophysicist Carl Sagan made the now widely used Kardashev scale formula to quantify these levels. It says level 1, 2, and 3 civilizations use around 1016 watts, 1026 watts, and 1036 watts of power. Comparatively, humanity uses around 2x 1013 watts. That makes us a ZO73 level civilization, still far from level 1. But we're hopeful we'll reach level 1 status soon. And level 2 isn't out of the question if we have enough time. Level 3 is off the table for now. Thing is, a level 2 civilization uses 10.26 watts of power. For us to reach that, we'd need to increase our energy use by 50 trillion times. Where could we get that insane amount of power? The biggest energy source in our solar system, the sun. The sun makes up 99.86% of all the stuff in the whole solar system. It puts out about 3.8 x 1026 watts. So if we could harness even a bit of the sun's energy output, we'd hit level 2 status. This brings us to the Dyson Sphere idea proposed by physicist Freeman Dyson in 1960. He figured really advanced civilizations would use a ton of their star's energy. They'd build a massive structure wrapping completely around their star to collect most or all of its power. These hypothetical megastructures are called Dyson spheres. So when humanity reaches level 2 status, does that mean we'd definitely build a Dyson sphere? A sphere could use stellar power super efficiently, but building one would be crazy hard. The biggest issue is getting enough materials. A structure enclosing the sun would have to be even bigger than the sun. But the sun has most of the matter in our solar system. Obvious problem there. Even with enough stuff, insane challenges would remain. Those include the strength and durability of the materials, keeping the sphere stable and heat-resistant, collecting and transmitting the power, maintenance, upgrades, and so on. Of course, what seems impossible now might not be for a level 2 civilization with tech we can't even imagine. Those civilizations could potentially solve all the issues with a Dyson sphere. But even if they could build one, it doesn't mean future humans necessarily would. With sufficiently advanced tech, there should be simpler ways to harness the sun's energy on a huge scale. Think of a bonfire. What's the most efficient way to collect and use its energy? Build a device around it? No way. The right move is to take away the bonfire's fuel and use it as needed. Similarly, we could take the sun's fuel and use it on demand. The sun's power comes from nuclear fusion, with most of the fuel being simple hydrogen nuclei, protons. If we could build giant spaceships to get matter from the sun and master controlled fusion with protons, we'd have virtually limitless energy. Although still extremely tough, this solar energy method seems way simpler than a Dyson sphere. It should be doable for a level 2 civilization. Notably, due to the radiation zone, hydrogen in the sun's outer layers can't reach the core fusion zone. So the sun only fuses hydrogen in its core during its main sequence. Even so, estimates say the core won't run out for about 5 billion more years. Why does the sun burn so long? Because it's freaking enormous. About 2x 1030 kg and 73.46% hydrogen. This gigantic fuel tank can power humanity for a ridiculously long time. More massive stars fuse hydrogen faster and live shorter lives. Huge stars typically last just a few million years. Smaller stars always live the longest. We can guess that if future humans removed matter from the sun, its mass would gradually drop. If we stopped around 845% of its original mass, the sun would turn into a red dwarf with an extremely long life. At least tens of billions of years, maybe over a trillion. In summary, while a Dyson sphere is one hypothetical way a level 2 civilization could harvest a star's energy, it may not be the only or best approach given sufficiently advanced tech. Directly using the sun's fuel could be simpler and more efficient. Either way, we humans still have a long way to go before hitting level 2 status. So how we'd harness solar power on that scale is speculative.